So yeah, good afternoon, everyone. I'm on the Simon team at Workday. We're Workday's search and analytics team. So the first thing you're probably wondering is, what exactly does scalably internationalizing millions of latent semantic labels mean? So in particular, what do we mean by semantic labels in this case, and what sort of scale problems do we run into when we're trying to internationalize? So that obviously requires some background, and it's somewhat specific to some tools that we've built. So I'm going to open up with a description of our original problem. We were trying to solve job title search. And then I'm going to talk about a tool we built called Clause that solves this using semantic labels. I'm going to talk a bit about how Clause uses those, a bit about how we build the semantic label data set for Clause, and then from there I'll seg into our internationalization approach, and then some validation results and next steps. So the original problem we set out to solve was job title search. So basically, if we were trying to search for job profiles or candidates in the system based on their job title. So one of the problems you run into immediately here is there are a lot of different ways to say the same sort of job title. So say I'm searching for a software engineer. Well, someone might call themselves a senior Java computer programmer. Someone else might call themselves a Ruby web developer. Someone else still might use like very small abbreviations and call themselves a senior UI enger. And someone else might use like random jargons and call themselves a JavaScript code ninja. So obviously you're going to run into a lot of problems with textual search here because software engineer is not going to return any of these results. These don't have software or engineer anywhere in them. So how do we solve that? Well, what we really need is some way to basically recognize the true semantic content of these job titles. So basically we need someone to say that computer programmer, web developer, UI engineer, and code ninja all kind of mean software engineer. So our solution to that is semantic labels. And we have a tool that does that. We call it Clause. So here I have, find my mouse. So here I have a Clause API tester. And I've put in our job titles. I don't know if any of you can see that far, but these are the same job titles I had on the slide. So senior, here, I can read them from here. So kind of senior Java computer programmer, Ruby web developer, senior UI engineer, and Python code ninja. I've also thrown in software engineer at the end for good measure. Wait, where is? What is that actually saying? Not found, 404. That's not good. Just a moment, sorry. Okay, so apparently my demo here isn't working, so I'm going to skip onwards. So what you would have seen there is when I pass Clause this list of job titles, it'll pass me back a bunch of data structures with kind of sets of labels for each job title. So for senior Java computer programmer, I would have gotten the labels basically job function, software development staff, specialization Java, seniority senior. For Ruby web developer, similarly, I would have gotten job function, software development staff, specialization web, specialization Ruby, again, software development staff for UI engineer, specialization UI UX, Python code ninja, kind of the same thing. And so basically the way you would use this in search is you would, at indexing time, you would take your resumes that have job titles associated, you would run the job titles through Clause, get back the labels, and you'd index those labels. Then at search time, you'd pass your query, software engineer, through Clause again to get another set of labels. And software engineer here will just give you back the label job function, software development staff. At which point you can use that to basically match on labels and get back the search results you were actually looking for based on the semantics of the query. So basically the basic idea is we break down these job titles into smaller meaningful components or ngrams. So back here we were talking about, we'll get back job function, software development staff for each of these titles. How do we actually do that? So if we take an example job title, say senior Java software engineer, what clause will do when it sees this is it tries to recognize the meaningful Ngrams in here. So software engineer will tell us that you're software development staff. Java will tell us that your specialization is Java. And senior should tell us that your seniority is senior. So kind of we're breaking this larger job title into the minimally meaningful components. Okay, so we know what our approach is. How do we actually do that? So clause under the hood actually stores a mapping from ngrams to labels. So the ngrams are these meaningful components. They're basically n-word phrases. And so here's a sample labeling, or a sample ngram to labels mapping. It's a bit dense. Here are ngrams. So Java is an ngram, and software application specialist is another ngram. And the labels are down here. So here this says that Java tells us that your specialization is software Java. Software application specialist tells your specialization is software applications, and your job function is software development staff. It's kind of hard to read in this form, so I've summarized in a little table. So here are some example ngrams and example labels. So in summary, basically, clause keeps a mapping of these ngram to label associations, and given an input, we will try to match the ngrams in the input starting from the largest first. And basically, in this way, we can decompose the input into a set of ngrams, and once we have those, we can return the labels that are associated with them through this mapping. So one of the benefits of this approach is it allows us to reduce the size of the space that we need to map. So basically, the way we train clause, we tend to start up with a sample set of 300,000 unique English job titles. And by breaking it down to the labels, we can describe it by only about 30,000 labels are in the system right now. In addition, once we've got the ngrams mapped, this approach can also allow us to map job titles that weren't into the original set, because you can kind of create new job titles by mixing and matching pieces. Going back to our example then, like I said, we're going to try to break this down from largest ngrams to smallest. So when we see senior Java software engineer, we will first pick up software engineer, the ngram, because it's the largest that we can find. Presumably we have no trigrams here. Then we'll pick up senior and Java. And like I said, because we're matching by ngrams, we can mix and match the pieces and still get the same meaning. So if I swapped out software engineer for computer programmer, I should still get the label software development staff. Likewise, if I swap that out for developer, I should also still get software development staff. Now, the second example actually isn't quite right. Developer is a little too general a term to tell you that you're a software developer. You might be, in this case, this person is a Java developer, but you could also be a real estate developer or an urban developer, right? So in this case, we need to give clause a little more context. So like I said, though, clause matches largest ngrams first. So we can give clause more context by essentially cheating a little and mapping a larger ngram. So if we map Java developer, and assign it both the labels software development staff and Java, we can still get the desired labels for senior Java developer without basically having this overgeneral term developer mapped to software developer. Yeah. Okay, so we've talked a bit about how clause goes about producing, basically recognizing ngrams and producing those labels. So obviously most of clause's intelligence is in this ngram to label mapping. So that leaves us the question, how is that mapping produced? So here, I actually have kind of our basic process for producing the ngram mapping. And long story short, it's a manual process. So what we do is we take those 300,000 job titles that we've sourced from the wild, and human data analysts will come and review those job titles. So when we source the job titles from the wild, we also have information on basically how frequently we see them. So a human data analyst will come in and look at kind of the most frequent job titles you see, and manually identify, okay, what are the interesting ngrams on this job title, and what are the correct labels that we should assign to them. Once they've labeled some ngrams, we can actually take that partial mapping that they've produced, feed it into clause, and try to label the entire sample job set. So what this does is it gives the data analyst a chance to review, see if they're doing something like overmatching, like mapping developer to software engineer and finding that all real estate developers are suddenly software engineers. And it also basically allows them to find basically what is now the most common unlabeled job title. So it gives them like where to continue mapping and some review so they can correct errors in their previous mapping. So once they review, they label more ngrams, we relabel using clause, they review, and so on and so forth. After enough iteration of this process eventually converges, and when the data analyst reviews the job titles, they'll say, okay, this mapping is now good enough. We have basically complete coverage over the sample set, and the labels seem more or less accurate. And at that point, they can publish the data set, and we can use it in production clause for enhancing our search results. Okay. So given that brings us to our problem of scalability. Basically, if we want clause to work in other languages, because of our n-gram-based approach, clause is only going to understand words that we've taught it. If we've only taught it English, clause is not going to understand French. On the other hand, we'd really rather not have to manually teach clause each language because the work our data analysts do is relatively specialized and pretty specific to our product. So it would be very manual and labor intensive to try to do this for every language. Moreover, even if we had infinite resources to throw at it, like I said, our data analysts do specialized work. We'd have to bring someone in and train them up on the process, and then they would have to catch up to the work our English data analysts have already done. So, of course, we'd like to do this better. Can we do that? And we think we can. So basically, to review, clause models the world using n-grams. And we can think of the process that the data analysts use to map those n-grams as the data analysts already know what their desired labeling on the universe of job titles is, right? So given a job title, they know, hey, this looks like a correct labeling for that job title. So kind of, if we think about it, if we already had a desired labeling of job title, we might be able to come up with an automated way to deduce the n-grams the analysts produce. Kind of the hard human part of this is knowing that base step of what labels belong on any particular job title. In order for that to happen, of course, we have a couple of prerequisites. One, we need a pre-labeled set of job titles. And we also need an n-gram structure that maps relatively cleanly. I'm going to come back to this point since it's not quite going to make sense just yet. But the idea for getting our pre-labeled set of job titles is we can take a set of foreign job titles and source translations for them. Once we have translations for them, English translations, since clause already understands English, we can use clause to produce labels for those English translations, right? And presumably, if our translations are good enough, those labels should be the correct labels for our corresponding foreign job titles. So this will get us kind of the desired pre-labeled set of job titles, at which point we can try to deduce the n-gram structure. Now, I had said that the n-gram structure needs to map relatively cleanly. Kind of what I'm saying here is bitexts need to work. I need to have some guarantee that if I have a set of French job titles, they'll have reasonably shared structure with the English job titles in terms of the words and concepts underneath. So kind of because our label set is in English, naturally our labels have some of the structure of the English language to them. But luckily, for the most part, we think this should work out. Like in these examples, for example, chirurgien means surgeon, orthopedist means orthopedic, cardiac, cardiac, professor, professor, neurology, neurology. So these all kind of like map pretty cleanly. There are some edge cases, like here, this example, professeur de université, sorry, my French accent is fairly terrible. Professeur de universités and médecine. This translates to senior university lecturer practitioner. This does mean the same thing, but we see some differences. Like professor translates to professor here it translates to lecturer. Medicine usually translates to doctor, and here it translates to practitioner. So we can hope that the labels on the English side are enough to figure this out, but we anticipate that there will be some cases where we'll run into issues here. That said, we still do expect that in the majority of the cases, we should be able to rely on shared structure. So kind of going back to the previous slide, the key step in this is how do we do the automatic n-gram deduction, right? How will n-gram deduction actually work? So kind of the underlying idea, if I argue it informally here, is if we have enough job titles that contain the same n-gram. So in this case, I've come up with I found a bunch of French job titles for various kinds of surgeon. So all of these job titles we would expect on the clause side, after we've translated and labeled it, to receive the label of something like job function surgeon. And moreover, if we look at these, all of these French titles share a word chirurgien, right? And in fact, it's the only word that all of these titles share. So we can probably deduce that chirurgien in French means job function surgeon to our label set. So kind of informally, that's the idea behind it. So let's kind of go over the overall process then. We built a tool called Laika that actually does this. So first what we do is we gather a representative sample of French job titles. We need to source English translations for these job titles. Now this, at its root, is still going to be manual, secretly, because for our purposes, like, automated translation isn't necessarily going to work. We need some specialized knowledge of how the job titles in this field are structured, or if we go back to the first slide, there were some, sometimes you get specialized abbreviations or jargon for job titles that automatic translation is not going to deal very well with. But luckily, like, this is still more scalable for us because translation is a relatively commonly requested service as compared to our task of n-gram labeling, which we definitely have to specially train people to do. Translation, we've managed to find third-party services that will actually find the appropriate specialists and translate the job titles for us for reasonable prices. So once we have those translations, we can produce labels for the English translations via clause. We'll assume that these are the correct labels for the corresponding French job titles because we assume we have a high enough fidelity translation. And then given the labeled French job titles, we'll try to deduce an n-gram to label mapping that produces the sample labeling. So let's try to run through an example of that. So I have here a very, very reduced hand-picked set of job titles. I've made sure that they have a fair amount of overlap in the n-gram, so we have some chance of learning what the labelings should be. So here I have chef de produit senior, chef de produit junior, chef de produit senior, chef de produit chef de projet senior, chef de projet junior. So this is kind of senior project manager, junior project manager, senior project manager, junior project manager. Right? So we've got the English translations, we've got the French job titles. We'll produce labels for the English and assume those belong to the French. And then the next step here is, given the labeled French job titles, deduce an n-gram to label mapping that produces the same labeling. Now, obviously, there's a lot of work that goes on behind the deducing. How do we actually do that? At a very high level, we basically want to examine all possible n-grams that could come from our initial set of job titles and see if they correlate well with particular labels. Now, obviously, we don't want to examine all possible n-grams, so we have some optimizations here. So here's a more detailed view of n-gram deduction. Given a labeled set of French job titles, we will consider a hierarchy of all possible n-grams. I'll get to what that hierarchy means in a moment, but basically it's, we form a hierarchy of n-grams by inclusion, and this yields a graph. So we can see kind of the largest parts of the top of this graph with labels from our French sample set, and then we can propagate these down into smaller n-grams. We have some rules on the propagation. We require that a label, if it's to be propagated, needs to belong to at least 2 parents, and it needs to occur to at least 75% of parents. These numbers were kind of arbitrarily picked. They could very well be further tuned, but they seem to be yielding reasonable results so far, at least for our initial runs of this. This is kind of dense and hard to understand, so let's look at some examples. So first, I'd like to review the universe of possible n-grams. If we look at any given job title, say chef de produit senior, naturally, so this is a 4-word job title, it's naturally going to have one 4-word n-gram, namely the entire job title. It will have 2 3-word n-grams, so these are basically just the runs of 3 words within the title. And similarly, 3 2-word n-grams and 4 1-word unigrams. So if we take the union of this across all our input job titles, we'll get kind of our universe of possible n-grams. And furthermore, if we look at them, there's an inclusion relationship between the smaller Ngrams and larger Ngrams. In particular, each smaller Ngram is fully included in some larger Ngram. It's a substring of it. So we can use that to define a partial order and get a graph out of this set of Ngrams. So now that we've defined the Ngrams hierarchy, we can go back to our steps. The next step is basically seed the graph with labels from our French label set. So as a reminder, here are the labels we got for our initial French job titles. We will add that to our hierarchy on the full forms of the job titles. At this point, we would like to propagate the labels. So I'm going to start off looking at one of the one of the largest unlabeled Ngrams. So this one is of size 3. It's shader produit. If I look at its parents, I notice that both of them have the job function product manager label. So this satisfies our criteria. It has at least 2 parents with the job function product manager label, and actually 100% of its parents have that label. So we cross the 75% threshold, we can propagate this label. We don't propagate either of the other labels because we only have one parent with a senior and one parent with junior. Next we can look at this node, de produit senior. This Ngram only has a single parent. So actually it cannot receive any labels. Because naturally none of its labels can occur on more than one parent. So actually it receives no labels, and we prune that node. And actually since we pruned it, this node now no longer has any parents. We'll also prune any orphan children that result because of previous prunings. In reality, we don't actually need to go and prune the orphan children. We just won't generate it when we're traversing this tree. So what we actually do is we generate each generation of children based on the previous survivors in the parent generation. So if we follow this through, then the next thing we do is we prune de produit junior and some children, prune de projet senior and some children. We do propagate one more label, the JF project manager, to shader projet. And actually the rest of this turns out to be pruning. So now you'll notice this isn't quite a perfect result. We haven't propagated senior or junior, but we have managed to figure out that shader produit means product manager and shader projet means project manager. And once we've done that, actually, we're basically done, because once we're done with this label propagation, the nodes that remain are essentially constitute the Ngram to label mapping that we were looking for. So let me see if this second demo would work. I had a demo set up for French job titles. Actually, I'm just going to skip that because I can't read this screen. So, so obviously we want to quantitatively know whether our approach is actually working. So we do cross-validation. So the sample set of French job titles we had was actually only 5,000 titles large. We do random sampled cross-validation. Obviously, standard thing. We withhold a part of the set as validation. We use the rest as training. And to actually calculate precision and recall, from the English translations in the validation side of the set, we can produce labelings from our original English Ngram mapping. From the French job titles, we can then produce labelings based on our derived French Ngram mapping. And then to calculate recall and precision, we basically do number of matched labels. We do it based on number of matched labels, false negative labels, and false positive labels. The recall and precision are worth looking into slightly further. I feel basically initially we wanted to come up with recall and precision based on match statistics on the Ngrams themselves. We quickly found that wasn't possible because any given Ngram is not going to necessarily be a full match with the original Ngram or a full mismatch. So here actually, we have chirurgien orthopédique is the French, orthopedic surgeon is the English. The orthopedic surgeon might produce job function surgeon and specialization orthopedic, whereas the French might produce job function surgeon and specialization cardiac. We can see that kind of the labels don't fully match or fully mismatch. But if we count by labels, we can come up with more well-defined match statistics. So here we can count job function surgeon as a true positive, specialization cardiac as a false negative, and specialization orthopedic as, specialization cardiac as a false positive, and specialization orthopedic as a false negative. So with that, let's take a look at the French cross-validation data. So here are some graphs. As you see, for French, actually, the data don't look so good. So we had about 5,000 titles, and consistently throughout our tests, precision hangs out around 50%, and actually towards the end actually drops to around 40% as we increase the sample size. Recall grows, but it maxes out at around 30%. So these results aren't very good, but we suspect it's because our French sample size is actually too small. Luckily, we have another much larger set of job titles, and that is English. English is very easy to translate into English. We just take the English. We can still test our method, though, because fundamentally what Laika is doing is trying to deduce an Ngram mapping from a job title labeling. So kind of trying to deduce a model that produces results. We can still do this for English. We just hide the model, right? So beyond that, everything is about the same. We have an original English Ngram mapping and a derived English Ngram mapping. If we look at these results, recall looks much better. So here we get to around 20% of our input set, and we're at 70% recall. This keeps rising to around 85%. Precision is still pretty poor, unfortunately. This consistently, it hangs around 60%. Now, I had mentioned we suspect that the French results are poor because we don't have enough job titles in the set, and the English bears us out some. If we look down here, around 1%, so this would be, so we have 300,000 English job titles versus 5,000 French job titles. Around 1%, so this would be around 3,000 English job titles, we're down to around 20 or 30% recall, which matches up with the French results here, actually. So hopefully if we continue this line, we'll get better results down the line. Yeah. So that said, the precision here is still worrying, because if we have 60% precision, since we are a search application, 60% precision on on job title search for resumes means that about half your candidates are coming back as bogus. Now we can improve these slightly if we consider weighted statistics. Basically, since different job titles occur with different frequency, we can basically weight our precision and recall by their frequency. And if we do that, this rises to something like 80%. But that's still pretty bad. 1 in 5 of your candidates are bogus results. So you still have to do a lot of manual sorting through them. So why is our precision bad? So I took a sample of some of our false positive labels here. So we have wind farm developer produces job function farming staff. Wind farm developer is also, for some reason, software developer. Solar fabricator is industrial manufacturing welding. PV applications engineer is software development staff, and software applications. This one actually kind of sounds believable, but I looked into it. PV applications engineer, I think, is actually someone who works with fuels. So this obviously, what? Photovoltaic. Photovoltaic. Oh, okay. So solar panels. Sorry. Yeah. So this person obviously should not be software development staff. And finally, we have payroll settlement specialist, where we get financial operations staff and payroll. So I took a look and kind of mapped back these labels to what the Ngrams were that were producing them. And if we look at it, kind of wind farm developer, it's kind of what you might expect. Basically, developer gives us the software development staff label. Farm gives us the farming staff label. Fabricator gives us this industrial manufacturing welding. PV applications engineer continues to be weird. Applications actually produces both the software applications and software development staff label. And finally, payroll produces payroll and financial operations staff. So if we look at this, we can say that basically most of our precision errors seem to be due to label overpropagation. So basically kind of the error I was talking about before, where developer gets mapped to software development staff. This is good news for us, though. It means we can probably tune this in by basically tuning our propagation. So this is a fixable problem and not a fundamental flaw of our approach. And I was going to cover, so kind of our, I think I'm out of time. So let's see here. So I'll skip the next steps and summary. If you guys found this interesting, as I said, I'm on the Workday Simon team, and we are hiring. My email is xiao.fan@workday.com. Email me if you'd be interested or if you just want to talk. I guess we can open it up for questions. Thank you. In the back.
Do you guys use this for applicant tracking systems for companies?
Yes, at the moment in Workday, we are we are building recruiting search. So basically for HR managers to search through their existing pool of candidates for ones they think they would match. So, yeah. And actually originally it was built so the Simon team was previously a startup called Identified, and they mostly did kind of the same sort of thing Indeed does. So.
As a second step, are you guys going to try and do anything in regards to skills or things like that?
Yes, actually. So job titles is the example I use, but we actually also map skills and majors. So, yeah.
Have you thought about other languages, like, Asian languages, which traditionally struggle a bit more with Ngram models? Or like, say, German or some of these compounding languages?
Right. So I've got to say, we haven't thought that deeply into Asian languages or German. Our hope is that basically with a good enough tokenizer, those should still break down into familiar enough Ngrams. Yeah. So actually, one of the things I listed on my next step slide that we created was we will need to do language-specific tuning. So for French, actually, we currently don't do stop words. If you were looking at my shade of produit slide, we could probably just drop the de and not lose any information. But for Japanese and Chinese, obviously, we need a good tokenizer.
And maybe follow up, do you see the manual process at all with like looking at like statistically interesting phrases or kind of driving, creating sample, that might be that, high co-occurrence words together, thinking that they might be better candidates than, in terms of the manual labeling process?
So you mean basically floating up?
Could you learn or create more of these automatically, like reducing your manual process?
Interesting. We haven't really looked into that, but that's an interesting idea. So basically looking at which words occur most frequently with each other and floating those up as potential Ngrams.
There's a lot of work on like statistically interesting phrases.
Yeah, no, that's, no, we haven't looked into it yet, but that sounds like a good idea. So.
Great, thank you very much.
Thank you.